We got everyone here?
Yeah, I think so. There we go.
Shall we get started?
Sure. Yeah, excited to have everyone come out tonight. This is a Boston New Technology event in partnership with Ikigai Labs. And just for some background, Boston New Tech's been around a little over 10 years. It started, really combination of startup showcase events, speakers, fireside chats and workshops, and it's grown a lot over the last 10 years, getting back to in-person events now too. So really excited to have this as sort of our kickoff back to in-person, and we'll be scheduling a few others over the summer, and then getting back to about once a month or so on a regular recurring basis across the Boston and Cambridge area. And yeah, I was really excited. Got to connect with the Ikigai team. We have Devav Raj here tonight, who's MIT professor and CTO of Ikigai, and really excited for his presentation. And I think you're all going to be impressed as well. So yeah, I'll hand it over to you to take us away.
That remains true at the end. But thank you so much for everybody for coming. Jason, thanks for helping us organize this. It was very valuable. So as Jason mentioned, I'm a professor at MIT, where I've been teaching statistics, machine learning, or what now all of us call artificial intelligence, for last 17, 18 years. And this is a room, for example, where I teach some of the classes. So really sort of nice to be back finally without masks. In fact, this is really literally for the first time after 2 years for me coming into these classrooms without masks, both of us. What I want to do today is we have an hour or so, maybe a little less, given sort of it's late in the day. What I'm going to do is very quickly give you context of where we are coming from in terms of building the low-code platform, in terms of Ikigai Labs, and what drove us here. I will try to keep it very brief. I'll give you sort of a few end use cases which you can sort of build very easily with Ikigai, and then sort of hopefully remaining 30 minutes or so, I would like you to walk you through sort of few, let's say, hands-on component that we have prepared for you. As a part of that, there is a page that you must have received. If you have not received, you should ask for it. And there's a first bullet item that's there. Is go and sign up on trial.ikigailabs.io. So just do that while you're listening. I'm pretty sure, like any other talk, there's a lot of information that's kind of redundant. So while I'm sort of giving you first few slides, you can just sort of sign up, make sure emails are there, and so on and so forth. And then we will get to that in 20 or 25 minutes. Okay. So with that, let's get started. So I think we can't start without sort of just talking about where it is the name artificial intelligence comes. So among my colleagues, one of them was Marvin Minsky, now ex-colleague. And one of the things that he did at MIT, which is introducing the name artificial intelligence. Okay, and I think in a sense, as one of my other colleagues jokes, I think maybe that was his most important contribution to the artificial intelligence, that is introducing the name, because it got us together around vision of saying that, well, machines will be capable. Okay. In 60s, when in the paper in which he introduced the word, this word, he said, well, in 20 years, machines will be doing what all people are doing. I disagree with that even now. I don't think that's going to happen. I think there are humans and there are machines, and together they will do lots of great things, not either or. But that's what sort of is the history of artificial intelligence, right? And again, goal has been always mimic human behavior in an intelligent manner. My view is that it's artificial intelligence aids and augments human intelligence and operational sort of strength rather than replacing. So with that, what we want to focus on, what I want to focus on personally, is how do we bring AI data and computation to help bring automation within organizations. And in my mind, this is like the hardest challenge of our modern times. Okay? if self-driving car is difficult, this is exponentially more difficult because humans are involved in that. In cars, at least, there are sensors and there are deterministic things, so to speak. It's not easy, but at least it's a prescribed setting. When you bring humans, then sort of suddenly all bets are off. So the question is that how do we think about doing automations in organizations? And that means that people have to be involved, and it should be for people. So how do we make people in organizations productive? By enabling them. And I believe that's an important and one of the most important challenge of AI right now. And if we start thinking from a very narrow perspective, then one way to sort of make organizations efficient is by thinking of them as financial instrument. At the end of the day, any for-profit organization is trying to make money. And so you're trying to sort of invest something into it and then get returns on it. It's a question, how do we think about making the organizations efficient as a financial instrument? And as I mentioned, human in the loop or human augmented AI is a natural way to do that. So really, our goal at Ikigai Labs is to help build tools that enable this end goal. Just to sort of give, just to quickly remind us where we were and where we have come. In organizations, if you think about key operations, there are two types: front office, which is people facing, and then the back office. And typically they're run by people, okay, with their skills, experiences, collaboration, instincts, passion, and lot more. In my mind, if there is organizations are people. If you take the people out, greatest of organizations will become useless. And once you realize that, then if you want to make organization more productive, you've got to make people more productive. And once you want to make people more productive, you've got to figure out how do we build tools for them. So with that, if we think of an era where before computers came, all the information in terms of data was managed through paper ledgers. Think of retail store in 1965. You're maintaining information about what products are there on shelves in paper, what products got sold, what products got purchased, and so on. Then came computers. There was 70s, 80s, 90s. Now we call it information technology. Data became digital, and once you got information digitized, you could build intelligence on top of it, which became business intelligence. But that primarily has helped us do strategic decisions. Machine learning predictions have gotten into some form of mainstream, but in my mind, predictions are means to an end, not an end. The question is, okay, so what if I have got a great prediction? If I don't know how to use it for the decision that I want to make, it's completely useless. And so really what you want to do is you want to help recommend decisions using the machine learning and predictions that you bring to the table. And there's always something that data misses. Whether your infrastructure is designed poorly or your intuition is missing or there's a part. So there is no way that data will capture everything. So you have to augment ability of humans to do that. Some form of operational task all the time. And so I would sort of call this how a life of data operator would look like. And I'm pretty sure so if you're very familiar with this type of situation. So first you would like to do, if you're going to use data for operations, is you want to know what is the ground truth, what is the data. Data might live in multiple places, which means that you're going to stitch information across different sources. Your first-party information, third-party information, all of them you're maintaining in different places, including some of the spreadsheets. So to get all of them in one place. Once you do that, then you want to stitch them to get the ground truth. For example, you have information about your you're selling products in e-commerce, and your information about what are the things out there in different warehouses. But maybe these products have expiry date. Now, the expiry date of these products is actually hidden into the PDFs that were sent to you by email by the people from whom you purchase the product, i.e. vendors. So now you've got to sort of get those PDFs, extract information from it, put it into some form of table, You also get information in terms of warehouses and what patches are there. Now stitch them together. These schemas don't match because no centralized person has designed all of these tables together. So now how do you sort of stitch it together? And this stitching problem would be in any form of data auditing, data reconciliation setting, where you've got more than one sources of information one way or the other, and you want to sort of bring them together to produce a ground truth. And that's the hardest problem at some level. Once you did that, then the question is that you will have choices, daily, weekly, monthly, quarterly. Which ones should you choose? Which one's action should you choose? And for each action, you want to sort of have some form of understanding of what its implication would be, so that then you can step back based on your constraint, based on your objective, you make a decision. Okay. So that will be the sort of the second part, where you would do all sorts of what-if analysis and so on. And then finally, at the end of the day, you have been running business for a while. You want to sort of every now and then look back and understand what sorts of strategic decisions should you sort of change or make. Okay. And this would be some form of collaborative task, some form of retrospective, some form of prospect. And you want to make this happen all together in one's day's life. And the key challenge that would come around there is, again, stitching data in multiple places, and then sort of enabling things on top without sort of becoming, requiring sort of big teams. This type of questions show up in all forms, and this is what sort of got us really excited about building the platform and the company Ikigai Labs, where think of whether it's inventory operations, whether it's marketing, whether it's accounting, claims auditing, or more general business operations. Everybody's asking the question, what's the ground truth? What action should I prioritize today? And how do I sort of make strategic changes? What worked, what did not work? So in short, to get more out of your investment, you want to sort of go through this process in as meaningful manner as possible, hopefully without requiring engineers to build new point solutions, because the moment engineers build point solutions, it'll take a while. And once it's built, something will change, which means you have to rebuild it again. And in either case, it's not going to sort of be, it'll sort of solve your problem. You don't want to change your day-to-day processes. So the question is sort of how do we build it with tools that can help, that work with you rather than you requiring. Let's see. It's back again. Okay. So if I sort of go to the next layer, some level, the type of task you would do is understand your data, after connecting it, understand, stitch it, build predictive models, interpret your predictions, do some complex modeling to decide what sorts of decisions you want to take, and then sort of make decisions and then put it into the downstream system. So, any questions so far? Any comments? I know this is not a classroom teaching, but typically, usually when I teach in a classroom, no student sort of let me sort of speak more than a few minutes, and they'll stop me. And here you guys are also attentive and let me speak, which means something is wrong. But in either case, let's see, everybody managed to sign up? Okay. Sorry?
Getting a limit exceeded exception.
Okay. All right, so while sort of he's signing up is sort of being taken care of, let me sort of explain how one would sort of try to address a question like this. And this is a day-to-day operational question for from the purpose of an inventory operations person who is trying to decide every day what SKUs to order or what products to order, how many of them, or what not to order. And again, goal is to maximize return on investment. There are constraints that one would have, and one way, at least a modern reinforcement learning style system would decide how to help that is, well, here's where you are. This is your current state. historically, if you had been in this stage, you've taken a bunch of different decisions, which one would help you best? And the one decision that have not been taken, how would that help? So let me show you sort of what you could, in principle, build within the Ikigai and how that would sort of help you solve this problem. And components of that we will build sort of in a few minutes from now. I'll sort of, I promise I will get to that. Okay, so let's see. Okay, so that's that. Okay. Let's see this one. Okay, now I can't see on this screen, so I'll have to put here. Okay, so this is your somebody's end-to-end supply chain template, and this might not be used by just one individual in an organization, maybe multiple, but this sort of encodes your entire process. Okay, so what is it doing? This is like your, as we call it, process diagram, because in many organizations you would have processes, but is the font too small?
Yeah, it's too smaller. I can't see from that side.
Okay, all right, let's see. I want to also make sure that all right, let's see. This might be better. Is it better?
For me, it's better. You don't want us to read it anyway. It's a bigger picture.
Thank you. It is about bigger picture. Yes, it is definitely about bigger picture, but in case you want to read. Okay, so this is digitization of your processes, and every organization has processes, every piece of the organization has processes, and typically it lives into people's head. So one thing we would, we like you sort of encourage here is that you should encode your processes through what we call process diagram. In fact, we say, well, you want to connect to data of all sorts, like sales data, purchase data, invoice data, product and component. If you're building sort of, you're making a cookie, but by dough and chocolate chips and all that. As you can see, I'm not good at baking cookies, but I'm good at cakes. But in either case, so putting the some different components, and then maybe you want to also understand your customers. This is simply a data. Inventory in retail, as we know, it's not a real information, right? It's a derived information. That is, what is my inventory? My inventory is what I purchased as a seller and what I sold, the difference of those two quantities. So it's never real. And that's one of the reasons why tracking inventory is really hard, because one would try to make an inventory table in a system, but it's a derived information. So real information is changing and things are out of sync, and there's always all sorts of errors. So tracking inventory for that reason is challenging, and you might as well sort of connect to source so that you can sort of track it in real time properly. You want to understand your things like sales, how well they work. So this, I would say, is data, stitching them together, and then doing a little bit of retrospective analysis. Then you want to do forecasting. You want to forecast different quantities. Once you've forecasted, then you want to do different scenario analysis, do basic reinforcement learning on top to determine, well, what sorts of products should I sort of order today, which might run out, and what sorts of policy should I follow? And first is a sort of system should generate a policy saying that, well, a human understandable policy is that whenever this phone, which I'm selling in my store, whenever the inventory of this store is left less than 3 days, I should order worth of 40 days. Okay. Now you might say, well, what is 40 days today? Well, 40 days today, it might be very different from 40 days from 10 days from now, right? Because demand changes. And that's where forecasting can help. And how did I decide on this rule? Well, I should look historical data, do all sorts of simulations, and based on that optimize it. So instead of going into all of these tabs, and given the time, let me just directly go to this policy analysis. So here are a bunch of policy simulations that we've done. There's the data. So anonymized, say, real data. And what this shows is that last season, this is roughly where I do want to you to read that. In last season, the first number says that there was an opportunity on the order of 900 plus thousand that was missed by you because you did not take good inventory decision. And while you were doing that, daily on average, 100,000 or so worth of money that you were investing in your inventory. So your financial instrument, you kept 100,000 invested into that financial instrument daily. Okay, it's like your S&P index fund in which you had put 100,000. And while you were doing that, you gained something, but you lost an opportunity of 900,000. So maybe if there was a way in which, in a causal manner, there was a scenario analysis where you could have followed different policy, maybe you could have sort of saved money. And this is one point that's showing that. It says about, actually, you could have, there is a policy where you could have kept roughly the same amount of invested in your instrument, i.e. inventory. It's 100,000, few less actually. And you would have missed opportunity worth of 590,000 instead of 900,000. So you could have sort of gained 300,000 with just by optimizing it. And how does one think about this? How can that happen, right? So here is just a very poor man's way of thinking about it in retail, right? So suppose I know, hypothetically, I know that I'm going to sell 100 products over an entire year. One way I can sort of stock inventory is buy everything upfront on day one of the year and then slowly sell it. Another is, I'll say, well, it's 100 things, so every 3 days one product is going to sell. And I want to sort of account for a little bit of fluctuation. So what I'll do is that every 10 days, I will order, or every 10 days, I will order inventory worth of 20 days. That's it. And now I'm keeping in my inventory only a few things, like 5 things instead of 100 things at any given point of time. And now suddenly my investment is reduced 20 times, but I'm making the same money. That's roughly what goes on, but of course in a complex manner. And once you do that, then depending on what you choose, your policy might update. Your policy might update, and that might lead to suggestions like saying, well, today it seems like these are the cues, all of them have, you should order, and maybe these are recommendations, these are the things you've already chosen. And I do want to order this because it's going to only cost me $1,200 more. And so I'm going to move it down here. I can save changes, go press button, PDF might be generated, it will be emailed, or it will be downloaded, or it will be sent into another integrated system integration. So all of these things you could do as a human in the loop, right? You as an operator deciding how much money you have. System can provide you recommendations. System should not automate anything. You have a question?
Yeah, so what you're describing is an optimization problem, right? I think you're trying to optimize for, let's say, minimal amount of inventory. But your optimization problem could be, is that the question that you're asking? Like,
so actually, I would say sort of, I'm not optimizing. Okay. And that's the point, because objective lives in my head, okay, as a decision maker. What I'm doing here is I'm trying to give you a few different scenarios, okay? Few different scenarios. And for those scenarios, I'm putting out few different performance metrics. I could have put out some other performance metric too. For example, let's just, I'm making it up, and so pardon me if this doesn't sound good. But let's say, how many different number of SKUs I have in my store, because that might be another thing that I might be worried about, right? So what I'm doing here is that I'm telling you, here are different knobs that you have, which are human interpretable. That is, if this SKU, for example, a policy may look like, for this SKU, whenever these many days of inventory left, you should order these many days or some such thing. Okay, I'm potentially reading something off here.
So you're saying that there is multiple problems. I mean, I'm not clear what problem you're trying to solve here. Right?
Yeah.
So
I'm not sort of, here's the problem I'm trying to solve. I'm trying to tell you that there are different levers that you have as a decision maker. Those levers in the context of this problem looks like for each SKU or each product in retail jargon, you tell me when should I order and how much at each time. One way to do that, as most retailers think about, is that for every product, you tell me how many days of inventory whenever it's left, you should trigger the alarm. And then at that time, I'm going to say, order for these many days. Okay. And that is a dynamic decision. Now, for given such policy, different metrics might work out. One is how much am I investing in my inventory? How much am I keeping in terms of my products in my warehouse? And so on and so forth. And then I have you as a decision maker has to decide which one of these options makes sense. But machine can help you make this easy. Objective is in your head. In a sense, when I teach reinforcement learning in machine learning class here, we have this beautiful theory there. It's amazing. Right? It's like you write down every reinforcement learning problem in that language, and after that you can just crank the machine. Like OpenAI has built the whole thing. The problem is that taking your real problem and writing down in that language, that translation or that is extremely hard, and we academics forget about that. So for me, this has been a great learning experience as I've gone through this journey a few times around. Anyways, yes, please.
As a decision maker, how do you know that data, the accommodation that the system is giving you is not biased?
Well, in this case, it's going to be as biased as your data is at some level. The question that we are asking is that are there methods who would are there methods who can help you remove the biases?
No.
Okay, and that's where, in my mind, the part where you build predictive models come in. So, for example, in this case, you build a forecast, right? Now, a forecast, for example, can be very biased because the data is very biased. Just to give you a very simple example, and this is a nice example. So there was a type of data set that was collected by people, but what they did is in it's a classroom, right? So let's see. On x-axis, for one fixed product, okay, that plotted price at which it was sold, and on y-axis, that plotted the demand that it would be generated at those prices. And people found that they had, and then if you fit simple linear regression, it would show something like this. So you would conclude that increased price, increased demand. Thank you for laughing. Turned out that, and I plotted it, there's two bubbles here. One bubble is for weekdays, and another one is for weekends. Okay. And if you model them properly, then it will look something like this. What happens is that on weekday, people shop less, typically. I don't know if that's true anymore, but people shop less than when this data was generated was true. People shop less, and hence people keep prices less, and of course, under that, if you increase price, demand would decrease. On the weekend, people know the demand is higher, but again, so you set prices high, and then you would see that. So really, it's confounded. There's a bias there. So you have to correct for these biases. And these biases you have to correct in things like how you make things like forecasting and all that. So you have to be clever about it. And okay, so anyways, let me I know it's 7:26, and I could continue with this. Let me show you one reconciliation use case, okay, which explains a little bit more about this human in the loop thing. So here is a simple data set. I hope the fonts are not too bad. So this is one data set that we generated based on the credits and debits. So the reds are negatives and the not reds are positives. Okay. If you look at it here, these are the two payroll entries which add up to this entry. So check money going out, money coming in, or the other way around, you're balancing it. So if you were to reconcile this, you would say these two should match with this one. But as you look at data and start looking at down there are things like cancellations, dates will become off, and so on and so forth. So then you will have to, as a human, you have to match these things. This is like when you're trying to reconcile transaction level. Okay? And some of the individuals I met here that did tell me that they're either they're dealing with taxes or dealing with financial stuff. So I'm pretty sure this is what one would call account receivable, account payable style reconciliation. Now, if you want to do this and you want to use some form of machine learning, so what we've done is in this one, what I did is I took that data and then just went ahead and ran certain machine learning functionality that's available in our platform out of the box, and it is reconciled and it has created clusters. Okay. Let me show you one cluster, how it looks. Let's see. Okay, so here is a cluster of 3 transactions, 2 negatives and 1 positives, and they all sum up to 0. So that's a good reconciled situation. So maybe I should say, yes, this is good, thumbs up, and save it. But on the other hand, you can look at something like, let's say this, where there are 6 things I've found, okay? And they don't fully reconcile, but they're almost reconciled. Given the amount, this is pretty small. If I look at it, this is for 131, this is for 131, 131. So maybe I should match these things, okay? Not all of this, sorry. Okay, but you see the point. And then maybe after that, I will sort of run the model training again, because these are the examples I've given to the machine, and the machine will sort of keep training on its own, and then keep producing. At the end, you can't do anything, so you will say, well, I need actually something, let's say, some system like this, which help me do matching manually, and then sort of save those things. The point is there is always human augmentation with system along with AI is what sort of our goal here in this plan. All right, I think I've said enough. It's already half of the time I've taken over. So let's see. You all have your trial account, okay. Now what I want to do is I want to go to let's see, my start here project, and so this is, so in your start here project, you will see these 3 folders, okay. I will tell you sort of what things I want you to do, because otherwise I will not give you the GPS and I will ask you to sort of follow each instruction. It will be extremely frustrating. I find it very frustrating unless somebody tells me where are we going, where are we ending. So I'm going to tell you that. It will not test your patience at all, okay, because it will be fun. And after that, there's a step-by-step version of those things that you can follow as by following video. Now, if there's not enough time and you have to go, you can sort of, the account will still remain active. Okay, so you can always go back and do it. But my hope is that as I show you sort of a few end-to-end videos just to show you what it looks like. So this is actually a platform. The platform has a project is a sort of standard workplace. Within each project, there are a bunch of components you have. The type of components I was showing you so far were dashboards, they're interactive dashboards, which you can build, drag and drop. You could have sort of data sources like databases. You can connect to all sorts of data sources. There's hundreds of connectors built in. So you can just go here and type in a new connector, and you will see some of these things in your thing. There will be, you can have your own data sets. Flows are the thing that you build with drag and drop, and we'll see some of them. And resources is somewhere where you keep information. So what I would do is that here's a one first end-to-end thing that we're going to do, and it's super simple. It's an alert design. What we'll do at the end is we'll build a solution which says that, let's suppose you are selling products in retail on Shopify, okay? And every time you go out of stock for some SKUs, you want somebody to send an email saying that, hey, you're out of the stock. Okay. Now it could have been very much like, go connect to Yahoo Finance, and every time S&P goes up, oh, this much, send me an email. So all of such things, this is just an example of it. So what I'm going to do here is I'm going to play the video, and sort of hopefully the voice will be audible. If not, I will speak. And it's built by Karthik sitting there, who has sort of put the video together. So if it looks great, thank him. If it looks terrible, it's all my fault. So here is just a YouTube link.
Here we're going to look at the alert design flow and go over
Is it audible?
what the different moving parts are and ultimately what the flow does. So we're going to start your project and we're in the flows tab. So you're going to click on the alert design. And we see this out of stock products flow. So we click on it.
I'm not sure why it's audio is
There's a
not
lot
playing.
of things open here.
Okay.
On the left and right, it's just telling us these are some things that you could input, these are some things that you could output. So we're going to close these tabs so we can get a better look at the flow in its entirety. So
what he's doing here is he's just showing this 4-step process, okay, which you will do following the step-by-step in a second, and I will leave you at your sort of will, so that if I stop annoying you. But what he's doing is showing sort of first facet is where he's showing how to sort of get data from a Shopify website for a given sort of, let's say, retail store. Then after that, he will filter, saying that what products are available and what products are not available, because it will get every product that's sold by that company. Then you can, so it's doing sort of the 2 copies. One is just saving it locally, another is sending it as an email to his own email account, and then you can just run. Okay. So that's what's going to happen, and I'm going to just play it now. And do pardon me if audio is not too high.
each of these blocks here is a facet, and arrows represent sort of connecting these facets, if you will. So our first facet, the start of the flow, is a custom facet called get products. And what we can do if we put this pencil is get a little bit more information about this custom facet. So facet name, and this is the official name of that facet. A valid Shopify URL and a company name. Now, quickly, if we take this URL, and we see this is a website on Native Pet, and they've got a bunch of products here, which we will see. So what this facet does is it scans the website and then gets all of the products into a data frame. Now, if we hover over this arrow here before we go.
So again, the idea is sort of any web page you want to scrape, effectively you can just do it with sort of this kind of boxes. So you don't need to write sort of, I don't know, in my time, I used to write this Python library called Spider and all that, but you don't need to hopefully do that.
For the next step, hit this peak arrow button. The peak allows you to see what is happening at each step of the flow, whereas running the entire project or flow will give you the output at the end. But sometimes it's helpful to see what is happening in between. So if we peek right here, we should see all of the products on the Native Pet website. So we see company Native Pet, we have the category, the name, the variant, the price, the product URL, and lastly we have this available column. Now this available column is important because we want to detect which products are out of stock. Now you see here we have all Boolean values, true or false, where true means that the product is available and false means that it is not available. Or in this case, it means that the product is out of stock, which is exactly what we want. So there's a very simple way to just filter out the ones that are out of stock. And we use this filter facet here. And once again, we can take a look at it, and we have just one simple expression, available equals false. And so now if we peek after this operation, the filter operation, we should see only the out of stock products, the ones that are not available. So that looks good. We have only the products that are false, and all of the information about those products remain the same. Now the last part before we export the data set is a data-driven alert. Now one thing that might be helpful is when there are out-of-stock products, we want to email a user, notify them that, hey, these products are out of stock. So using this copy facet, in which we just make 2 copies of the data after it's been filtered, one of the copies we're just going to export export to a data set so that we have it, and call it out of stock output, and save it as a CSV. And the other one we're going to use to notify the company, anybody that these products are out of stock. So looking at this facet here, it's another custom facet, and the arguments that it takes in are email address, using mine for now, subject, body, and date of month. So if we run this flow, what should happen is we should get an export and output data set, and we should also receive an email containing the data of the out-of-stock products. So that ran pretty quickly, and if we see here, just got this email that contains these products which are out of stock, and that matches up with the output data here. In the next video, I'm going to show.
Okay. So that's the first part. Okay. Now there is a step-by-step guide for this. I'm going to skip, but I'm going to let you sort of see it and build it in a bit. I want to sort of show the second part, which is just doing a little bit of auto ML forecasting, and then sort of there's a third part which is for your homework. So all of those things are there in the folder. So let me just run through another such thing, and then at least give you some time to at least play with it. If you already want to start playing with it, feel free to skip it because these videos are already available in those pieces there. So with that as an understanding, I'm going to start this piece. You can watch it, or you can sort of continue, start building your thing with your step-by-step guide. And there are some of the team members that are here, so in case you have questions, feel free to sort of raise your hand.
In this video, we're going to be looking at the entrepreneurial portion, and I'm going to give an overview of this forecasting flow. So if you click on it, and let's view the flow. We've got a lot going on, so we'll start on the left here with the start of our flow, which is our imported data. And if we peek here, before we do anything, we can get a sense of what this data looks like. So we've got a date column, which is important to us because we know we are dealing with some time series data. And we have all of these quantities for these different columns. All of these different items and a lot of different quantities. So now that we know what the data looks like, as an overview here, what we want to do is we want to make some sort of prediction about what the quantities of these items are going to look like in the future based on the data that we have. So what we want to do is we then want to be able to take those predictions and view them in a dashboard that makes it easy to see, what is the real data and then what is the predicted data, and have that all in one data set so that we can visualize it with the dashboard. So the first step is to copy our original data. So what we want to ultimately do with these two copies is one copy is just going to stay the same, it's our real data. And then with one copy, we're going to use that copy to predict some future values for all of these quantities. And then we're going to merge those two
The cross-validation
predictions with the real values so that we have everything in one data frame. And then we can go about creating a dashboard. So we make two copies here. And as you can sort of tell, this branch over here is going to be the predicting branch where we make our predictions. And this is going to be our original data that will end up getting merged. So we'll take a look at the top branch and this select facet where we can select our target columns. We can select what columns we want to focus on here. And of course we have to select the date column because that's the most important thing, the time series data. And then we were arbitrarily selected 5 of these, and those could be any of the items that we were interested in. And similarly on the bottom here, we're going to select those same 5 as well as the date column. Now on the top, we're going to create a new column in our data, and it's just going to be called prediction type. It's going to be real prediction type, and we will see that our predicted values will end up going into that column right there that we just created. So now on our lower branch, this is where the bulk of the work is being done, the predict facet. So we edit this facet, we have a time series model, and once again, we have these same 5 target columns, and now we specify our time column to be the date. Now, future interval, we just put 30, and as you can see, there's some parameters here for the confidence and variance and whatnot. We will leave those as they are. So now that we have our new column created and we have our predictions, we want to merge these two so that we have one data set with all the values. So we have this union, this merge right here, this merge. And on top, we want our real values, and on the bottom, we're going to have our predicted values. And then finally, we're going to export our data set. So we can take a look at the data right before we export it, and we see here that these are our real predictions, real values, and then if we scroll all the way to the bottom, we get our predictions. So there's an upper bound and a lower bound and a predicted value for each of these items.
So they're like 95% confidence interval plus.
So now when we run the data and export this data set, we will get this auto output, and we have created this chart for a dashboard where we can see, in this case, I've selected bean cake to look at, and we can see all of these values are the real values. And then over here on the right, we have our predicted values. And we have confidence intervals here. They're sort of bunched together, so it's a little bit difficult to see them, but you can see here our predicted values in upper bound and lower bound. And since we concatenated the data into one data set, it's easy to view it all. So we have our real and then our predicted. So this was an overview.
Right, so I think those are the two pieces there, and then there are these associated step-by-step videos associated with that, so hopefully you can go and build all of those things. I know you have left you 15 minutes, so not much, but at least would give you some flavor of it. And of course, if you have questions, feel free to ask me. Otherwise, at least the instruction part of this this conversation is over.
Feel free to raise your hand if you want to get some assistance or feel like you're struggling.